Ever feel like you've read something important, but I don't know, a few days later, it's just gone?
Yeah. Like smoke.
Exactly.
Yeah.
Or maybe you're facing like a big learning challenge and wish there was a more reliable way to make information truly stick.
Hmm.
What if the key to learning wasn't just about putting in more hours, but maybe understanding how our brains are actually wired to learn?
That's really the core puzzle that cognitive psychology tries to solve.
Okay.
Essentially, it's the science of how our brains handle information, how
Huh.
we take it in, process it, and sort of store it away for later.
Right, like looking under the hood.
Exactly. Looking under the hood of your mental machinery for learning, it really moved us beyond just watching what people do
Uh-huh.
to actually understanding the inner workings,
Mm.
how we pay attention, memory functions, how we solve problems, that kind of thing.
Okay, so instead of just like guessing at study techniques, cognitive psychology gives us a more scientifically informed approach.
That's the idea.
In this deep dive, we're going to explore some of the learning strategies that come from this understanding.
Precisely. We're talking about strategies backed by evidence, not just, anecdotes.
Right.
And when you understand the cognitive principles at play, the why behind what works, you become a much more strategic learner, more effective.
Yeah, that makes sense.
It's like finally getting the instruction manual for your brain when it comes to learning and remembering things.
That sounds incredibly useful.
Mm.
So what are some of these fundamental brain processes that are so critical for learning?
We'll focus on a few key areas today. First, attention, how we filter and focus.
Yeah.
Then perception, how we interpret what our senses are telling us.
Right.
Next up, memory, the big one. Encoding, storing, retrieving information.
Mm-hmm.
And finally, how we build these mental frameworks, schemas, to organize all this knowledge,
Seen as us, okay.
understanding how these processes work, and importantly, where they can sometimes, stumble, is really key to seeing why certain learning methods are better than others.
Got it. So the mission for this deep dive is really to give you, our listener, some practical, science-backed strategies, things you can actually use.
Yeah, to learn more effectively, more efficiently.
We're aiming to provide maybe a bit of a shortcut to becoming a more strategic and confident learner. So let's dive into these core cognitive processes. You mentioned attention and perception first.
Right. All learning really starts with our ability to focus. Think of attention as a spotlight,
Okay.
highlighting what's important from the constant flood of information around us. Cognitive psychologists talk about selective attention.
Zooming in.
Yeah, zooming in on one thing, ignoring distractions and divided attention. That's trying to handle multiple things at once. Multitasking.
Which we all try to do.
We do. And then perception kicks in. That's our brain interpreting the sensory info that our attention has allowed through, trying to make sense of it all.
And I think we can all relate to that temptation, right? Multitasking,
Right.
trying to listen to something while checking email or scrolling your phone while reading.
Oh, absolutely.
Is that where things start to go wrong for learning?
It really is. I mean, it feels efficient sometimes doing multiple things.
Yeah.
But the truth is, divided attention really hinders our ability to deeply learn complex stuff. Think of your brain like a bottleneck.
Okay.
Trying to force too much information through at once just restricts the flow.
Yeah.
Deep learning needs space.
Right. Limited resources.
Exactly. Our brain's resources are finite. Split them, and the depth of processing for each thing just suffers. For really absorbing new information, you need that sustained, focused attention. It's the gatekeeper to the next stage,
Mhm.
memory.
Okay, let's explore that next then, the fascinating world of memory. It's not just one big storage closet in our heads, is it?
No, not at all. Memory works in stages. First, there's encoding.
Encoding.
Yeah, like translating new info into a language your brain gets so it can be stored.
Okay.
Then comes storage, holding on to it, and we usually differentiate between short-term or working memory.
Like a phone number you just heard.
Exactly. Limited capacity holds things temporarily. And then long-term memory, which is vast, more permanent storage.
Right.
And finally, there's retrieval, getting that stored information back out when you need it.
Yeah.
Accessing it.
And how we first encode things seems really important for remembering later. You hear about different ways to rehearse information.
You're spot on. There's elaborative rehearsal.
Elaborative.
Yeah, where you really engage with the meaning of the new information, connect it to what you already know. It's deeper processing.
Mm-hmm.
That creates much stronger encoding than, say, maintenance rehearsal.
Which is just repeating it.
Pretty much just repeating a fact over and over without really thinking about what it means. It's superficial.
Okay.
And retrieval is super important too. It's not passive. It's an active process. And the very act of successfully pulling out information actually strengthens the memory itself.
Yeah.
Think of it like a path in a forest. The more you walk that path, retrieve the memory, the clearer it gets. Easier to find next time.
That's a great image. The act of remembering helps you remember better. So all those hours spent just passively rereading notes, maybe not the best use of time.
Unfortunately, often not.
Yeah.
Rereading gives you this superficial sense of familiarity.
Oh, we have seen this.
Yeah, I've seen this before. But that often leads to weak encoding. It doesn't build strong pathways for retrieval. It's like recognizing a face in a crowd versus actually being able to describe that person later.
Right, big difference.
Active retrieval, on the other hand, forces your brain to work. To pull the info out, that's what builds durable knowledge.
Now, you also mentioned schemas earlier. These sound like the mental frameworks we use to organize everything.
That's a really helpful way to put it. Schemas are like mental blueprints, frameworks.
Okay.
They help us organize and interpret info based on our past experiences, our prior knowledge, like your brain's filing system.
Makes sense.
So when we encounter something new, we first try to fit it into our existing schemas. That's called assimilation.
Like seeing a new kind of dog and just thinking, okay, another dog.
Exactly. You assimilate it into your dog's schema. But sometimes the new info doesn't quite fit, and we have to adjust our existing schemas or maybe even create new ones. That's accommodation.
Like learning about, I don't know, a whale. It lives in water, but it's a mammal, not a fish.
Perfect example. You have to adjust your mammal or fish schema. This process can sometimes create a bit of mental friction, a state called disequilibrium.
Disequilibrium.
Yeah, which then motivates us to adjust our understanding to reach a new state of balance or equilibrium.
So these schemas, they influence what we pay attention to, how we learn new stuff, and even how easily we recall information later.
Absolutely. They act like filters, influencing what we notice and how we interpret it. They give us a structure for encoding new info, making it easier to understand and remember.
Okay.
And they play a big role in retrieval, too, helping us access relevant information more efficiently. So building accurate, flexible schemas is a huge goal of effective learning.
Flexible is key there, right?
Definitely. And sometimes encountering information that actually challenges our existing schemas, what some call desirable difficulties, can lead to much deeper understanding as we work through those contradictions.
This is all incredibly helpful background. Okay, now let's get to the really practical stuff. What are some of these science-backed learning strategies we can actually start using? You mentioned retrieval practice.
Yes, retrieval practice. Also known as active recall or the testing effect. It's probably one of the most powerful tools we have.
And it's simple, right? Just trying to remember things.
At its core, yes. It's simply the act of actively trying to recall information from memory. And the science behind it is incredibly robust.
Okay.
Decades of research consistently show it's far more effective for long-term retention than just passively reviewing stuff. Like, way more effective.
Better than just rereading.
Oh, much better. It works across different ages, subjects, timeframes. Studies even show it beats out strategies like concept mapping or just repeated studying for long-term recall.
Wow. Okay, so we should probably rethink just rereading our notes then. What are some concrete ways to actually do retrieval practice?
Lots of straightforward ways. Low-stakes quizzes are great, even just mentally quizzing yourself after reading a section. Flashcards are fantastic, but the key is to really try hard to recall the answer before you flip the card. Don't just flip it immediately.
Right, the effort matters.
Exactly. The two things, activity after a lesson or reading, just jot down the two main things you remember.
Simple.
Brain dumps, literally just writing down everything you can recall about a topic without looking at notes.
Okay.
Or even generating potential test questions for yourself. And it's not just for school subjects. It helps in demanding fields too, like neurosurgery training. Improves complex skills.
It sounds almost too simple to be that effective. Why is just trying to remember something so good for learning?
Well, there are several key reasons. First, like we said about memory, the act of retrieval itself strengthens that memory trace, makes the path clearer. Second, it introduces that desirable difficulty. The effort involved, especially if it doesn't come easily, signals to your brain, hey, this is important, hold on to it. And third, it massively improves your metacognition.
Your awareness of what you know.
Exactly. Your ability to accurately judge what you actually know versus what you think you know. This helps you focus your future study time way more effectively.
That makes perfect sense. Sometimes I feel like I know something just because it looks familiar when I reread it.
Totally.
But then when I actually need to recall it later, like on a test, it's just blank.
That's exactly it. That feeling of familiarity is so misleading. It's a classic metacognitive error, mistaking recognition for actual recall. Retrieval practice forces you past that illusion. It makes you confront what you truly know, leading to much more durable knowledge.
Okay, retrieval practice. Got it. Another strategy you mentioned was spaced repetition. That sounds like it's all about the timing of review.
Precisely. Spaced repetition, or sometimes called distributed practice, is basically reviewing material at increasing intervals over time.
Increasing intervals.
Yeah. It's based on the spacing effect, which shows learning is much more effective when study sessions are spread out, not crammed together.
Right, the opposite of cramming.
Exactly. The idea is you revisit information just as you're starting to forget it.
Ah, okay.
That forces your brain to work a bit harder to reconstruct the memory, strengthening it against that natural forgetting curve we all experience.
So instead of one huge study session right before an exam, it's better to do several shorter sessions spread out over days or weeks.
That's the core idea, yes. New or difficult stuff might need more frequent review at first, but as you get more comfortable, the time between your reviews can gradually get longer and longer.
And this is well supported too.
Oh, yeah. Very strong evidence across many different areas, learning languages, medical knowledge, you name it. It can even help people with memory impairments.
How can we practically implement this? Does it mean keeping a super complicated calendar?
It doesn't have to be. It can be simple or sophisticated. Physical flashcard systems, like the Lightner method.
Where you move cards between boxes.
Yeah, that's a great low-tech way. Or there are tons of excellent digital flashcard apps now, Anki, Quizlet, lots of others. They automate the scheduling using algorithms.
Oh, neat. They figure out when you should review.
Exactly. They predict when you're likely to forget something and prompt you to review it then. Or you could just simply schedule regular review times in your own calendar, maybe reviewing notes weekly, then biweekly, then monthly.
And what is it about this spacing that makes it so much better than cramming?
Several things. Reviewing just as you're about to forget seems to be the sweet spot for reinforcing a memory.
Okay.
It forces that active recall we talked about.
Mm-hmm.
It also allows time for memory consolidation, the brain process that solidifies memories over time, often during sleep.
Consolidation.
Spacing also helps reduce interference between similar pieces of info, and ultimately it just leads to much, much better long-term retention. Many digital tools even adapt, showing you stuff you struggle with more often.
Personalized spacing.
Right. And importantly, spaced repetition and retrieval practice work together beautifully. Spacing tells you when to retrieve, and the retrieval is the act that strengthens the memory.
They're like a team.
A power couple for learning.
Okay, interleaving was another one you mentioned. That sounds a bit different, like mixing things up.
That's exactly right. Interleaving means mixing different topics or different types of problems or different skills within a single study session.
Instead of doing one thing completely before moving on.
Right. That's called blocked practice, doing all of problem type A, then all of problem type B. Interleaving mixes A and B together in the same session.
That feels harder, maybe less efficient. Wouldn't it be better to just focus on one thing until you nail it?
It feels harder initially and maybe slightly less efficient in the short term. That's true. But the research is pretty clear. Interleaving often leads to much better long-term retention and more flexible knowledge. You get better at applying what you know in new situations.
Okay, interesting. Where is it particularly helpful?
It's especially good for what's called inductive learning, figuring out underlying rules or patterns from examples. And for any task where you need to distinguish between different categories or problem types and choose the right approach. Think learning different artists' styles or solving various kinds of math problems or even learning grammatical structures.
So how would we actually do this? Give me an example.
Okay, math is a classic one. Instead of doing 20 addition problems, then 20 subtraction problems.
The blocked approach.
Right. You do a mixed set, addition, subtraction, maybe multiplication, all jumbled up.
Yeah.
For each problem, you first have to figure out what kind of problem it is before you solve it.
I see. So you're practicing identification too.
Exactly. Or in language learning, instead of drilling all the food vocabulary, then all the clothing vocabulary, you'd mix them up in your flashcards or practice sentences. Okay. Musicians might alternate practicing different scales, different pieces, or different technical drills within one practice session.
And what's the cognitive magic behind mixing it up like this? Why does it work better long term?
It forces your brain to constantly discriminate. You have to identify the type of problem or concept each time, and then retrieve the correct strategy or information from memory.
Unlike blocked practice where it's obvious.
Right. In block practice, you know what to do because you just did it 5 times. Interleaving creates contextual interference.
Contextual interference sounds bad.
Yeah. The name is a bit misleading. It means the learning context is more challenging, more variable. But that extra effort during practice leads to more robust, more flexible learning later on.
Okay, so the struggle is productive.
Very productive. It forces more retrieval from long-term memory, prevents that blocking effect where focusing too long on one thing makes it hard to switch, and it strengthens the association between the type of problem and its solution. Keeps your brain more engaged too, arguably.
Interesting. Okay, dual coding theory was another strategy. Sounds like using two formats.
Exactly. Dual coding theory from Alan Pivio suggests we process and store information in 2 main ways. Verbally, using language.
Words.
Right, words. And non-verbally, using visual and other sensory information, images, sounds, etc.
Okay.
The core idea is that learning is significantly boosted when we represent information in both formats simultaneously. Think words paired with relevant pictures.
That makes intuitive sense. Picture's worth 1,000 words and all that. Is there good science behind it?
Oh yeah, quite a bit. Studies consistently show we remember verbal information better if it's paired with a relevant visual, or even just if we actively create a mental image to go along with the words. Neuroimaging studies also support it. They show verbal and visual processing happening in different, though interconnected, brain areas.
Different systems working together.
Exactly. It lines up well with principles of multimedia learning, too, the idea that well-designed combinations of words and pictures are effective for instruction.
So how can we listeners use dual coding when we're trying to learn something?
Lots of ways. Look for or create diagrams, charts, infographics, timelines, maps to go with text.
Visual aids.
Right. When taking notes, try visual note-taking like sketch notes or concept maps. They combine words and simple drawings.
Okay.
Actively try to create mental images as you read or listen. If you're reading about, say, the water cycle, picture the evaporation, the clouds, the rain.
Visualize it.
Use analogies that create vivid images. Making abstract ideas concrete through imagery really helps.
And what's happening in our brains when we do this? Why is it better?
It basically creates multiple retrieval pathways.
2 ways to find the memory.
Exactly. If you have both a verbal and a visual memory trace, you've got 2 hooks to pull that information back later. The systems can also work synergistically. The visual makes the verbal more concrete. The verbal helps organize the visual.
Okay.
This builds stronger connections between the systems, strengthening the overall memory. But big caution here, the visuals have to be meaningfully related and complementary.
Right. Not just random clip art.
Definitely not. Irrelevant pictures can actually hurt learning, increase cognitive load unnecessarily. They need to clarify or illustrate the verbal information.
Got it. Okay, last one on the list was elaboration. This sounds like going deeper.
Precisely. Elaboration is all about actively expanding on new information, explaining it in detail, connecting it to what you already know, making links.
Connecting the dots.
Yes.
Yeah.
Techniques like self-explanation, explaining concepts in your own words, maybe out loud and elaborative interrogation, asking yourself how and why questions are key here.
So it's not just memorizing facts, but really digging into the meaning and the connections.
That's the heart of it. The scientific basis goes back to ideas about depth of processing.
Deeper processing equals better memory.
Generally, yes. The more deeply and meaningfully you process information, connecting it to your existing knowledge structures, the better you'll understand it and remember it long term. Elaboration forces that deeper processing.
Can you give us some specific examples? How can we do elaboration when we're learning?
Sure. When you encounter a new concept, ask yourself, how does this work? Why is this important? Why is it true? Then, try to answer those questions in your own words.
Okay.
Try explaining the idea to someone else, even an imaginary person. That's self-explanation.
Teaching to learn.
Exactly. Generate your own examples that illustrate the concept. Think about how this new information relates to stuff you learned last week or to your own life experiences. Compare and contrast it with similar ideas.
So if I'm learning about, say, photosynthesis.
Instead of just reading the definition, you might ask, okay, why do plants need sunlight for this? And then you try to explain the role of light energy in converting CO2 and water into glucose, connecting it maybe to your understanding of energy or food chains.
Right, building those links. And how does all this deeper thinking help our memory and understanding?
It fundamentally helps integrate the new information with your existing knowledge. You're weaving it into the fabric of what you already know.
Creating a richer web.
Exactly, a more interconnected web. By generating more connections, you create more potential retrieval cues, more pathways back to the information later.
More hooks?
More hooks, more anchors. The act of explaining and connecting also helps you organize the new material meaningfully. And it's an active process you're constructing understanding, not just passively absorbing. Plus, trying to explain often reveals gaps in your own understanding.
I thought I knew this, but I can't explain it.
Precisely, which is incredibly valuable feedback. It shows you where you need to focus more effort. Elaboration is really about sense-making.
This has been incredibly insightful. We've got these powerful strategies, but just knowing about them isn't enough, right? We need to be aware of how we're learning and adjust things. That sounds like metacognition.
Exactly right. Metacognition, often called thinking about your thinking, or maybe more usefully, learning how to learn.
Okay.
It's absolutely crucial for actually using these strategies effectively, selecting the right one, applying it, monitoring if it's working. It's about being aware of and regulating your own learning processes.
So what does that awareness actually involve? What are the parts of metacognition?
Well, there's metacognitive knowledge. That includes knowing yourself as a learner, your strengths, your weaknesses, knowing about different learning strategies like the ones we've discussed, and knowing when and why to use them, and also knowing the demands of the learning task itself.
Okay, self-knowledge, strategy knowledge, task knowledge.
Right. And then there's self-regulation, which is a core part of metacognition. It's the ability to actively manage your learning through a cycle.
A cycle.
Yeah, typically seen as planning, monitoring, and evaluating.
Okay, can you break down that cycle for us? Planning, monitoring, evaluating.
Sure. Planning is upfront. Setting clear goals for your learning session. Selecting the strategies you think will work best for this material and this goal. Allocating your time and resources. Thinking before doing.
Okay, then monitoring.
Monitoring happens during learning. It's checking in with yourself. Am I understanding this? Can I explain this part? Is this strategy actually helping me learn, or should I switch? Identifying tricky spots.
Like hitting pause and checking the map.
Exactly. And evaluating happens after the learning task, reflecting on the outcome. Did I meet my goals? What worked well? What didn't? Why? How can I adjust my approach next time?
It sounds like being much more intentional, more strategic about the whole process. Why is developing this so important?
Because, honestly, a lack of metacognitive skills is a huge reason why people stick with really ineffective study habits.
I guess just rereading.
Like just rereading, yeah. Even if they vaguely know there are better ways, they might not accurately judge how well they really understand something, that illusion of fluency again, or they don't realize their methods aren't leading to lasting learning. Developing these skills gives you control, makes you a self-directed learner.
So what are some specific things we can do to boost our metacognition? Practical tips.
Okay, for planning, maybe do a quick pre-assessment. What do I already know about this? Analyze the task. What exactly do I need to be able to do with this information? Consciously choose your strategies. For this, I'll use flashcards with spaced repetition. Preview the material, maybe generate some questions beforehand.
Good prep. What about monitoring during learning?
Regularly pause and ask yourself questions. Try to summarize sections in your own words without looking. Use the muddiest point technique after a study session. Identify the one concept that's least clear that tells you where to focus next. And be willing to switch strategies if one isn't clicking.
Don't just keep banging your head against the wall.
Right. And for evaluating, compare your results to your goals. Did I learn what I set out to learn? Look at feedback like on quizzes or assignments and try to understand why you made mistakes. Tools like exam wrappers.
Exam wrapper.
Yeah, where you analyze your test performance. What kinds of questions did I get right, wrong? Why? What does that tell me about my understanding and my study methods? Keeping a learning journal can also help you track your process over time.
And you mentioned earlier, judging your own knowledge can be tricky.
Very tricky. Remember, testing yourself after a delay, not immediately after studying, gives you a much more accurate assessment of what's actually stuck than just relying on that immediate feeling of knowing.
Good tip. Wait a bit before testing.
Yeah. And remember, metacognition isn't one size fits all. You need to adapt your strategies to the specific subject, the specific task. Ideally, we need explicit instruction on how to learn effectively within different disciplines.
This connects to another idea I've heard about, cognitive load theory. It sounds like it's about not overloading our brains.
That's a good way to think about it. Cognitive load theory, or CLT, focuses specifically on the limitations of our working memory.
That temporary mental workspace.
Exactly. The place where we actively process information. CLT tries to optimize learning by understanding and managing the amount of mental effort or cognitive load involved in a task.
And I think there are different types of load.
That's right. CLT usually distinguishes three types. First, intrinsic load. This is the inherent difficulty of the material itself. How complex is it? How many elements do you need to process simultaneously? Learning simple vocabulary has low intrinsic load. Understanding, say, quantum physics has very high intrinsic load.
Makes sense. What's next?
Extraneous load. This is the unnecessary mental effort. It's imposed by things like poor instructional design, confusing explanations, distractions. It doesn't actually help you learn the core material. It just gets in the way.
Bad load.
Bad load. We want to minimize this. And the third type is germane load.
Germane.
This is the good kind of load. It's the productive mental effort you spend on deep processing, understanding the material, building those schemas, making connections. This is the effort directly related to learning.
Okay, so intrinsic is the difficulty of the topic. Extraneous is bad design distractions. Germane is the useful effort for learning.
You got it. And the total load is the sum of all three, since our working memory capacity is limited.
Finite pipe.
Finite pipe, exactly. The goal is to reduce the extraneous load and manage the intrinsic load to free up as much working memory capacity as possible for that crucial germane load.
How can we do that? What are some techniques to optimize cognitive load, either for ourselves or if we're teaching others?
Okay, to reduce extraneous load, clear, concise presentation. Good visual design, make sure visuals are relevant, uncluttered, and integrated well with text. Don't make people split their attention unnecessarily. Sometimes using audio and visual can be better than just visual alone, the modality effect. Eliminate redundancy. Minimize distractions.
Basics of good communication, really.
Pretty much. To manage intrinsic load, the inherent difficulty. Activate prior knowledge before diving in. Break complex information down into smaller, manageable chunks, maybe learn sequentially, segmentation. Pre-train essential concepts first.
Scaffolding the learning.
Exactly. And to promote that good germane load, use work examples, especially for beginners. Encourage active, generative strategies like self-explanation, summarizing, concept mapping. Provide varied practice. Give people enough time to actually process.
It sounds like a balancing act.
It is. And interestingly, what helps a novice can actually hinder an expert.
Oh, how so?
It's called the expertise reversal effect. Highly detailed instructions or worked examples that are great for a beginner can become redundant and just add extraneous load for someone who already has strong schemas in that area. They don't need the hand-holding.
Fascinating. And it seems like the strategies we discussed earlier connect here, too.
They absolutely do. Dual coding can help distribute load across visual and verbal channels. Elaboration helps build those schemas that eventually reduce intrinsic load for familiar tasks because you can chunk information more effectively. Managing cognitive load provides a really useful lens for understanding why these other strategies work and how to design learning experiences better.
You've consistently emphasized active engagement throughout this. Let's really nail this down. Why is being active so much better than just passively taking information in?
Okay, let's draw a clear line. Active learning means your mind is on. You're engaging with the material, maybe creating a response, making a connection, asking a question, trying to solve something.
The line's on.
Mind's on. Passive learning is more like being a recipient, just listening to a lecture without really thinking or taking useful notes, or just rereading a text without critical engagement.
And the benefits of being active are pretty clear.
Hugely beneficial, well documented. Active learning leads to better engagement, more motivation, you're more invested. Crucially, it helps you construct your own understanding. You build better, richer, more connected schemas, and this leads to better performance on all sorts of measures: recall, problem solving, application. But the key is cognitive engagement.
Not just physical activity.
Right. You could be doing a hands-on activity, but if your mind isn't truly grappling with the concepts, it might not be that effective cognitively. It's about the mental effort.
And how do strategies like retrieval practice, elaboration, interleaving, how do they fit into this active learning picture?
They are active learning techniques, fundamentally. Retrieval practice, you're actively searching memory. Elaboration, you're actively making meaning and connections. Interleaving, active discrimination and strategy selection, dual coding, actively processing in two modes and linking them. Even spaced repetition usually relies on active retrieval during the review sessions.
So they force that cognitive engagement.
Exactly. They demand that active cognitive work. That's why they lead to stronger memories, deeper understanding, and more durable learning compared to just passive exposure. And there's a bonus. When you're actively involved and see yourself making progress, it often makes learning feel more rewarding, more intrinsically motivating.
That makes a lot of sense. Okay, we've covered a ton of ground on effective learning. Let's maybe flip it now and talk about some common pitfalls, those bad habits many of us fall into. First one, the illusion of fluency.
Ah, yes. The illusion of fluency. A classic. It often comes from those passive strategies like rereading and maybe excessive highlighting.
My old friend,
Yeah.
highlighter.
Yeah. These things make the material feel familiar. But that feeling of ease, that fluency, is super misleading.
How so?
You mistake the ease of recognizing the information when it's right in front of you for actually understanding it deeply or being able to recall it later without the text. Recognition is easy, recall is hard.
Right.
These passive methods just don't involve the effortful processing needed to build strong memory traces, those clear paths for retrieval. No desirable difficulty.
So all those hours highlighting sentence after sentence probably didn't achieve much on its own.
Likely not as much as you'd hoped if it wasn't paired with active strategies. The physical act feels productive, sure, creates a false sense of accomplishment. But without deeper engagement, the learning is often shallow and fleeting.
Okay. Pitfall number 2. Cramming. We've all done it. Why is it so bad for actually learning things long term?
Cramming, or massed practice, fails mainly because it violates the spacing effect we talked about.
Right. Spreading out is better.
Massively better for long-term retention. Cramming might let you temporarily stuff info into short-term memory for an immediate test, sometimes.
Yeah, maybe pass the quiz tomorrow.
Maybe, but it doesn't allow for memory consolidation. Your brain needs time and spaced review intervals to really solidify those memories for the long haul.
Okay.
Cramming usually involves superficial processing, maybe rote memorization, not deep understanding. It creates high cognitive load, lots of stress, and it's often just a sign of poor planning and poor metacognitive regulation. You wouldn't need to cram if you used spaced practice earlier.
Guilty as charged sometimes.
Yeah.
And the last pitfall, distractions. It feels harder than ever to focus. How do they mess up our learning?
Distractions are a huge barrier, both external ones, phone notifications, noisy environments, and internal ones, like your mind wandering. They fragment our attention, and attention is that limited resource, remember?
It's the spotlight.
The spotlight. When it keeps getting pulled away, the depth and quality of your information processing just plummets. Every time you switch away and then try to re-engage, there's a cognitive cost.
Takes effort to get back on track.
Exactly. It increases that useless extraneous load, makes it way harder to get into deep processing, build strong memories, achieve germane load. And yeah, today's digital distractions make this a constant battle, requires real conscious effort to manage.
And potentially has longer-term effects on our ability to focus.
There's definitely concern about that. If we get too used to constantly fragmented attention, it might become harder to sustain the deep, focused concentration needed for complex learning and thinking.
Wow. Okay, this has been incredibly thorough, really eye-opening. So just to kind of wrap up the core message, understanding how our minds actually learn through cognitive psychology.
Yeah.
It shows that actively using specific strategies like retrieval practice, spacing, interleaving, dual coding, elaboration, these are just way more effective than passive methods.
That's the bottom line. These aren't just random tips. They're techniques grounded in how our brains actually work. They align with the cognitive machinery.
Right.
And adopting these, along with working on our metacognition and managing cognitive load, sets us up for much more effective learning, not just now, but lifelong learning.
And it takes effort, for sure. Changing habits isn't easy.
Right.
But the payoff.
Huge payoff. Deeper understanding, much better retention, better problem solving, more confidence as a learner. It's absolutely worth that initial effort. It's a journey, really.
The journey of experimentation.
Yeah, experimentation and adaptation, using these cognitive principles as your guide.
Okay.
So maybe a final thought for you, the listener. Don't try to do everything at once. Choose just one, maybe two, of these strategies that resonated with you today.
Start small.
Start small. Consciously try to incorporate it into whatever you're learning right now. Pay attention. See what difference it makes to your understanding, to your retention. What new insights do you gain about your own learning process?